In this video we explore the structure and principles of the Estonian construction project standard EVS811-2012. We will break down key topics including the definitions and responsibilities of stakeholders, the roles of the clients and how the project documentation is compiled and managed. We also cover the main phases of design and integration of the engineering and building systems, the importance of quality control and the practical use of tools, like building information modeling. By following this framework, construction professionals can ensure reliable results, consistency, communication, strong cooperation and legal compliance across every project. The Estonian standard for construction project EVS811-2012 was created to unify and update previous standards for the building and facility construction. It revises EVS811 buildings and EVS907 for facilities, forming a single framework that covers all stages of a construction project. This new standard provides more detailed explanations about design process, principles and the roles of different parties involved. It also places a great emphasis on the importance of the client responsibilities and requirements through the project. The main goal of this standard are to simplify construction documentation, standardize terminology and definition, and enhance cooperation among the various stakeholders involved in construction project. By streamlining these aspects, the standard aims to improve the overall quality and efficiency of the construction project in Estonia. Multiple organizations contribute to this development of this standard, including Association for Architects and Engineers, the Estonian Road Association, universities like TalTech and government bodies, and so on. This broad involvement ensures that the standard reflects the needs and experts of the entire industry. One of the critical points highlighted in the standard is the client's vital role in the design process. For construction project the success, it's essential to establish a clear and well-defined project task or scope from the very beginning. The responsibilities of the client must be clear, identified as their input and guidance is fundamental in achieving desired final results. The standard shows that the workflow starts with the client task, proceeds with development of the design team, and ends with the final outcome. The standard has been in effect since it was published in May 2017. It was developed by the EVS working group, focusing on the construction project, and work was led by Indrek. In summary, the Unified Estonian Standard for Construction Projects streamlined guidelines, clarifies roles, improves collaboration and raises the quality of the clear project, with the special attention given to the client responsibilities. Guidelines and standards are essential for managing construction project, ensuring consistency, safety and quality through the process. At the core, the standards define the scope and the field of application, reference and key regulation, and provide important terms and definitions related to construction and design, including works should be organized. The main concept centers around the project stages and the process. All construction projects begin with the initial project data, which includes basic input data collected as an outset along the updates at the different milestones. The project then follows the structured development process, beginning with the general principles that guide every decision. Project stages typically progress in three main steps: preliminary design, main project design, and the working project design. Preliminary design serves to clarify project requirements and approaches early on. Next, the main project design goes into further details, defining the technical aspects and refining the design for practical execution. Finally, the working project design prepares all necessary details for actual construction and project completion. Project leadership and roles are clearly defined. The principal designer is responsible for preparing and starting the project, managing technical and designing content, ensuring coordination across all design fields, and maintaining project control and quality management. Application of construction standards extend into specialized design fields. External and civil infrastructure includes planning for external spaces such as landscaping, designing roads and traffic structure, organizing public lights and arranging external utility networks for electricity, gas and data, as well as heat and water supply networks. Within building project there are specific architecture and internal categories. This includes building architecture, which covers the overall structure and aesthetic design. Internal design focuses on the functional and ergonomic spaces, acoustics and lighting, optimization, comfort and usability, and fittings and lock systems for safety and access. Building engineering and systems are also a crucial focus. These standards cover structural engineering of load-bearing frameworks, fire safety measurement and heating, ventilation and air conditioning systems, mechanical smoke control, plumbing, drainage system, fire protection installations such as sprinklers and gas installation. By following these structure guidelines covering everything from general definitions and detailed technical application, construction project can reliably achieve regulatory compliance, meet safety standards, and deliver high-quality results for all stakeholders involved. Building electrical and automation system involves the design and integration of essential systems for power distribution, communication, automation, and safety within the structure. A comprehensive approach ensures seamless system integration across these critical domains. At the core is the use of building information modeling, or BIM. BIM technology is applied through the entire construction project lifecycle, beginning from preliminary stages through the basic project phases and into the detailed work project stages. This digital modeling supports accurate collaboration and information decision-making from initial planning to the final stages of execution. The project development process starts with the sketching, which covers both the external and internal of the building, as well as associated roads and site infrastructure. Those sketches form a basic for detailed design solution, which address the use of reinforced concrete, steel and timber products suited to the unique requirements of the project. The technical reviews by experts ensures all solutions are robust, practical and compliant with the standards. There are several critical system categories and engineering controls involved. First, power and communication includes both high voltage installation such as substation and main panels and low voltage installation like network racks and security systems. Next, automation and efficient measurements focus on the building automation system, such as HVAC and lighting controls and energy efficiency technologies that minimize operational cost. Fire safety systems are integrated to provide automated fire protection and alerting. Additional quality assurance is prioritized through the design, supervision and construction project management to ensure the work meets all necessary standards. These technical solutions are put into practice across the project life cycle and its ongoing management. Initial steps include applying for building permits and accurately estimating the cost of the construction, operation and maintenance. Throughout procurement and construction, various contractual approaches are used, and support is provided during the construction phase. As the building nears completion, special attention is given to the handover and future operation, preparing user and maintenance manuals, ensuring the smooth transition to the building management teams. Consultancy services are also of crucial importance, providing expert advice and technical support as needed. In summary, integrated engineering solutions for building electrical and automation system combine advanced digital tools, structured design and process, and rigorous technical controls. This approach ensures buildings are safe, efficient and well prepared for long-term operation and maintenance. This standard is designed for professionals in the construction industry, including building designing, professional clients, construction management, owners, supervision specialist, authority construction specialist, and other. Non-professional users are advised to seek guidance from qualified construction consultants. The new standard unifies requirements for both building and civil engineering facilities, replacing previous separate standards. While there are many different types of construction projects, a unified approach is now used for all kinds, whether building roads, landscaping, or other facilities. because the underlying principle for preparing and construction design projects are similar. The key focus on the standard is over the content and level of the detail, including the design documentation, rather than the strict formatting rules. The aim is to prioritize the quality and clarity of the project solution and the information presents, allowing flexibility for new and evolved methods to present information in the future. The central to the approach is expectation of the good faith cooperation. All parties involved in creating and construction design projects are expected to act honestly, share information, collaborate, and work towards common goals. Trust and teamwork amongst the client, designers, and all contributors is essential. The standard responds to the notable lack of Estonian language literature and in-depth guidance on organizing construction design work. It provides much more detail than previous standards, clarifying the principles of design organization, the role of each party, the process, and the relation between the design phase and other construction activities. This prevents a situation where each participant develops their own unique approach, ensuring consistency and shared understanding across the industry. The major point emphasis is the critical role of the client in achieving quality result. Success begins with a well-prepared, meaningful project brief that defines the requirements. The standard highlights of the client responsibilities preparing this brief and collaborating with the design team throughout the project. The entire project team joins effort, starting with the client, is vital for high-quality outcome. Application of the standard is illustrated through the examples, such as preparing through the client brief, following an integrated design process, and achieving results in projects ranging from modern office building to roads, parks, and so on. By applying those consistent standards, the encourage cooperation, project can reliably achieve its result. This standard provides a framework for preparing construction project documentation. It applies to buildings, utility networks, roads, outdoor spaces, landscaping, and similar structures. While the core principles can be used for other types of structures, the standard specialty excludes public roads and private roads intended for public access. The main focus is the managing and guiding the design work across different development stages of a construction project. These stages begin with the concept phase, progress through the preliminary and detailed planning, and concluded with the construction phase. For each stage, the standard clarifies the type and the level of information required. It also defines how the design process fits into overall construction project and highlights the relationship with the construction-related consulting services. The standard does not address how project documentation should be formatted or presented, whether on paper, digital, or building information model. It also does not provide detailed guidance on specific design solution or demolition project. Requirements for demolition are covered in separate legal acts. To ensure proper project planning and documentation preparation, the standard should be used alongside the relevant legal acts that regulates how construction project must be composed. Its role is illustrated within the large framework that includes legal requirements and other standards that require materials, all of which work together to support the planning and documentation of construction project. This standard provides the main definition for construction project and design work in Estonia. When there are differences in the definitions and instructions about the project stages design work, the information presented, or the level of detail required, the definitions are instructions and standards. However, because building projects vary widely, the standard is not designed to serve as a fixed template for assigning or preparing construction project tasks. A central concept in this standard is the building project lifecycle. This covers every activity from the original idea through the investigation, design, construction, and finally commissioning, where the completed building is put to use in the client. This process follows 5 main steps: idea, investigation, design, construction, and commissioning. The key professional role and services are defined to clarify responsibilities. Building consultancy service refer to technology-based intellectual service that address construction or the natural environment. The experts providing this service are called building consultants, who possess construction competences and deliver technological knowledge-based advice and solutions. Design work is described as a consultancy service that creates and develops solutions for architecture and engineering needs. This design process builds the foundation for the entire construction project. The design scope includes not only building, but also landscaping and internal architecture. Construction work, as defined in this context, gathers together all the activities necessary to achieve the construction result. This includes processing materials, supervising work, and documenting each stage. Construction work covers tasks performed directly on the construction site, as well as the manufacturing elements of site and their later installation. To summarize, this standard provides clear guidance on terms and workflows for the construction sector. It ensures consistent definitions for the project stages, clarifies the key tasks and consultants and designers, and the sets of shared understanding for how building project proceeds from the initial concept to complete and use. A construction designer, such as architect or engineer, is responsible for creating and planning solutions for architecture and engineering projects. This person prepares the necessary construction design documents and, more broadly, may also serve as construction consultant. The building life cycle spans from the construction phase through the eventual demolition, and all design and planning occurs within this range. The process typically starts with the main concept or concept design, also known as esquisse. This is a preliminary draft that sets out the general principles of the spatial solution for planned building part or other project. The concept design illustrates the key idea and overall solutions, complete with the explanations, and serve as the starting point for more detailed construction design documentation. Construction design documents or aids project are developed during the project and document preparation process. The content depends on the stages of the design and must include all necessary information. These documents are used to assess the suitability of the architecture and engineering solution, estimate the project cost, check the compliance with the relevant requirements, organize construction procedures, and guide the construction to the building of its part. Notably, even the documentation of the building demolition or demolition design is included under this category from legal perspective, despite being more related to the construction technology. Technological design is especially part of the documentation that describes planned technological processes such as catering, production, or waste management within the building. It details the equipment, logistics for storage and handling, and stages of construction requirements for the building and supporting technical networks. Technological design can serve as essential input when compiling construction design documents. Finally, every building has two important time-related concepts: building life cycle and intended service life. The building life cycle refers to the period from construction to demolition. Intended service life or design working life is the intended duration during which the described load-bearing structure or other parts of the buildings are expected to maintain their condition and performance, taking into account environment and required maintenance. If the structure is properly maintained, it should not deteriorate below expected levels during this period. This framework ensures that every construction project is planned, designed, and executed in a structured way, considering both the technical and the practical aspects needed for a reliable and safe built environment. Construction supervision in building project involves three main types. First, supervision by the owner relies on the competent experts to consult during the construction. Their main tasks are to verify that the building structure or its parts comply with the construction design and check the construction technology is correctly used. Second, construction supervising by the authority is a form of national oversight. It ensures that all construction activities comply with the requirements set by the law. This supervision is carried out by bodies specialized in legislation. Third, designer supervision provides consultation during the construction from the designer who created the project plan. This includes explaining design solutions when needed and resolving issues or discrepancies within arise due to the difference between the project documentation and actual site conditions. Project stakeholders include both the owner and the construction site, who is the person entirely ordering the completion project, and the owner of the construction design, whom the designer creates the building plans. The design owner could be the site owner, a consultant or main contractor, or the design building contractor. A crucial element in design process is the design brief. This written document prepared by the design owners expressing their wishes and requirements to the designers. It contains the owner's needed requirements, limitation in architecture and engineering, as well as the work program conditions and specific constraints for the project. The design brief serves as the central reference for the design, incorporating owner-approved conceptual solution. To ensure the final output is appropriate for the project, specialists such as architects, engineers, or even acoustics may be involved, especially from the technical demanding project. The design process is divided into stages known as design phases. Each phase marks achievement in the level of detail of the construction design and is distinguished by the special goal. Phases follow each other in order. For example, beginning with the preliminary design, followed by the basic operation, and eventually as a build documentation as the project progresses and completed. This framework of the supervision types, stakeholders roles, and design briefs and design stages creates a structured approach to the management quality, compliance, and the progress of construction project. A building project moves through a clear life cycle, transforming requirements into complete structure. First, there is an initial and feasibility phase, where the basic needs or possibilities are assessed. Once this is completed, the project enters the design stage, which are divided into key parts. The first design stage is called the preliminary design or e-project. This is the least detailed phase. Here, the basic solutions for the project and the general description of its quality are represented. Its main goal is to lay out the principle and provide enough information for the clients to review and approve the direction before more detailed work begins. After client approval, the project advances to the detailed stage, the põhiprojekt. This second stage provides more specific about how the project will look and function and describe the solution in much greater details and defines the expected quality. At this stage, designers become detailed enough to set the project budget and start organizing construction tenders. In other words, this phase is crucial for getting accurate cost estimation and preparing for contract bids. At last and most detailed stage is the preparation and construction working document, or tööprojekt. This document is laid out of the technical details necessary for building and quality supervision. This phase defines the exact solution and specifies the required quality for every element. Importantly, in actual practice, construction work can only begin once these documents are ready. The preliminary and detailed design alone are not sufficient for static on-site work. The success of the design and construction process depends heavily on clear roles and responsibilities. For general contractor, for design or projekteerimispeatöötaja carries contractual responsibility for every part of the design, for overall integrity and for ensuring the project quality. Overseeing project development is head designer or peaprojekteerija, who manages coordination and ensures that all parts fit together properly, supporting them in the design management of projekteerimisprojektijuht, a competent individual who organizes and coordinates the entire design process. The design team of projekteerimisrühm is a consultant group made of a specialist, each responsible for different project parts. This team works collaboratively under the guidance of the lead designer and manager, ensuring fully integrated and cohesive project result. In a typical building project, the application of these stages is straightforward. The preliminary design is used mainly for zoning and initial client approvals. The detailed design allows for accurate building and preparation of construction offers. Construction actually begins only after working documents are completed, which provide the instruction for execution and quality control. Throughout the project, governance and coordination by the key roles mentioned ensures the smooth flow and work and the integrated design approach. This structured process helps transform project requirement into safe, functional and reliable complete buildings. Exterior spaces refers to the design environment outside the interior space of the buildings. This includes areas shaped by the building, natural elements, cultural influence, and social factors. Facilities and structure located outside the interior of the buildings are categorized as a competence of the exterior spaces. The primary concept within this subject is construction works. Construction works are a result of human activity connected to or supported by the ground. There are two main types, building and civil engineering works. Buildings are structures that are separate from the environment by roofs and other building elements, creating a defined interior. Civil engineering works, on the other hand, are construction that do not qualify as buildings, such as roads or buildings. Small exterior structure, often called minor civil engineering works, are integral parts of exterior spaces. Example includes fences, gates, retaining walls, pavilions, and so on. These are laid out according to design and functional principles of enhancing and organizing exterior spaces. Important construction principle is the load-bearing structure. This is an organized collection of the connected elements specially designed to carry loads and provide structural stiffness, ensuring the stability and durability of the construction. Another essential concept is the building envelope. Building envelope elements create a physical and functional barrier either within the building or between the external and internal environments. Their purpose is to separate spaces, control environment exchange, and contribute to the building as an overall performance, especially in relation to energy efficiency and comfort. Design-built products are construction components or assemblies that are manufactured in the factory according to the special product drawings, which are based on the building project documentation. Precast reinforced concrete elements are a typical example of the design-build project. Finally, moisture safety or moisture proofness is crucial in all construction work. It involves ensuring that the building and its elements are designed, built, and used in a way that prevents moisture damage. Proper moisture control maintains the building's durability and healthiness throughout the life cycle. Understanding those definitions helps clearly to define objects and concepts fit into broader context of design, exterior spaces, and construction works. Understanding the building environment starts with the knowledge of key concepts used in engineering and construction. It's important to define terms clearly for accurate technical communication. Moisture damage refers to problems like the breakdown of materials, growth of microorganisms, and harmful chemicals reaction, all due to excess moisture. These issues can affect both the structure and the health of the occupants. When discussing parts of door, the term door hardware or door furniture includes complement like locks, latches, and closer, but specially excludes hinges and automatic door sweeps. Building services systems, often called MEP systems, are central to help building operate. MEP stands for Mechanical, Electrical, and Plumbing Systems. Together, those include all those equipment installation and communication lines within the support instruction needs for building operation users and safety. For example, this includes systems for ventilation, heating, and electricity. A technical installation is a fixed functional system made up of equipment and the necessary connections. Examples include electrical and ventilation installation, which are permanently installed and essential for the building to function as intended. Moving outside the building, we talk about utility networks and routes. A utility network covers external pipes, cables, and structures that provide services like water supply, sewage, heat distribution. A route or trace describes the design path for things like pipelines, power lines, and roads, essential mapping where the infrastructure runs across land. All those building systems and networks must be well documented. A design document is a key part of the process. It's a special document within the design project that explains the document solution and includes other important project information. Together, all those documents make up what we call design documentation. Finally, there are also a list of design documents, which is an organized list of the documents that collectively make up the complete network design. This helps ensure every detail is occurrence for which supports both building and function and safety. Comprehensive construction project documentation includes all the documents needed throughout the life of the construction project. This involves both technical description and graphical illustration to provide a complete picture of the project from planning to completion. Project information in the construction documentation is divided in two main types, textual and graphical. Textual project information focuses on describing project solutions and other relevant details in written form. This includes tables, lists, explanatory notes, instructions, and drawings, and comments or annotation in building models. Common example of textual documentation are the design notes or explanatory notes, which provides clear narrative or explanation of the project decision and technical approaches. Graphical project information, on the other hand, represent detail preliminary through the visual formats. This includes drawings, diagrams, 3D digital models, and the building information model. These graphical elements allow stakeholders to quickly visualize the project layout, systems, and structural components. When detailing technical systems within the construction project, several specific diagram types are used. The technical system structure diagram explains the main solution principles and shows where the major equipment and service groups are located within the building. This is essential for understanding how technical systems interact within the spaces they serve. The technical system operation diagram illustrates how systems function. It shows how the arrangement of the equipment components, connection, and technical parameters, and provides description of how each part operates within the overall system. For electrical systems, single line diagram is often used. The diagram simplifies the multi-conductor circuits by representing all conductors as a single line, while still indicating the number and types of conductors. Standard symbols are used to represent elements like transformers, fuses, and switches, making those diagrams easy to interpret and specialized. Another key document is the general plan or technical system. This is detailed plan of view, often with elevation, showing both the design and existing technical equipment within the building. It indicates their location and helping to assess the coordination between building structure and the technical system and ensure compatibility. Application of those documents are broad and include construction research reports, site location studies and sketches, and initial design, overall project documentation, permits, and so on. Together, those documents support the entire construction process from early planning through ongoing building management, ensuring that all stakeholders have the information needed to build and maintain the function-safe and efficient structure. In construction project, a range of technical drawings and models is used to guide the planning, design, and building process. Each type of drawing serves a special purpose and contains different kinds of information. A site plan or assembly plan is drawing that shows how buildings and landscapings are arranged on a given area based on topological survey. It displays the existing situation, proposed changes, elements that are to be removed, and also shows how the site connects with the nearby roads and surroundings. This drawing may also represent information about elevation, but for clarity, elevation details might be shown separately. The service network's comprehensive plan or technical plan builds on the site plan by including all service networks, such as water, electricity, and communication lines. It shows the location of the existing planned and to be removed infrastructure. This allows the designers and engineers to evaluate if these networks are compatible with the rest of the site and with each other. A shop drawing or tootejoon is created for the manufacturers of a special construction project. It includes technical details required for the fabricating a component in the factory and goes beyond what's shown in the general drawing. Assembly drawing or koostejoons provide instructions for the assembling, inspecting, and testing products that are put together from individual components. These drawings belong to the manufacturing field and help ensure that each part is correctly integrated into whole. Installation drawing or paigallusjoons are used for the actual construction work on site. They contain step-by-step instructions for installing prefabricated product or building systems, ensuring everything is placed on the connected as intended. This may also be called montage drawing. Survey drawing or mõõdistusjoons are prepared during building investigations. They show the real measurement, dimensions, and location of parts of existing buildings. This type of drawing is crucial for documenting the actual state of the construction for renovating, expanding, or analysis purpose. The major development in construction documentation is use of BIM. BIM is a three-dimensional digital representation of the building, and it's part of capturing both physical and functional characteristics. The model may store additional information like who made specific components, cost, and schedule. Within BIM, it's possible to design and coordinate all project aspects digitally, a process often called BIM design. A BIM coordinator manages the BIM process, ensuring models from different design disciplines are combined actually and stay comparable from technology standpoint. This role is key to maintaining the flow of information and success project coordination. Together, these various drawings and digital models ensure that every step in construction project from initial design to final installation is well documented, coordinated, and based on accurate technical data.